All right, so C4. C4 I am calling solving quadratics using any method. Okay, so before we start going through and practicing these solving steps, let's go over the methods that we know of solving quadratics. So, you may or may not be aware of this, but you happen to know 4 methods to solving quadratics. Does anybody remember what the 4 methods are? Quadratic formula is one of them. Okay, the square root method. Whoops. Square root. Okay, good. Whoops, oh my gosh, I can't. That's not going to read. Square root method. We did factoring. And there's one more. I don't know if you'll remember the 4th one. Formula, oh, what the quadratic formula is? I could do that for you. Goes negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, so anybody want to take a stab at the 4th method? Starts with a G. What? Yeah. Good guess. Graphing. Okay, we did graphing like one day. We didn't spend a ton of time on it because it's not my favorite method and it's not usually extremely efficient, in my opinion.
He's dropping out. He just moves signature right there.
Thank you.
Yeah, thanks.
Okay, so in talking about these 4 methods, when can you, or maybe when can't you, use them? So for the quadratic formula, can you always use the quadratic formula? Yep, as long as it's set equal to 0. The next. So yeah, you can technically, as long as it's an x squared quadratic, then you can use the quadratic formula. If there is a term that's missing, like the b value is missing or an a value is missing, you can just fill it in with a 0. So you can always use the quadratic formula to solve a quadratic. Okay, what about the square root method? Can you always use the square root method? No. Okay, so the square root method can only be used when the b value is 0. That's the only time that you can use the square root method. Okay, what about factoring? Can you always factor quadratics? Are all quadratics factorable? No. Okay, so factoring does not always work. Sometimes it works and sometimes it doesn't work. So it's not always the best method. Okay, what about graphing? Can you always solve by graphing? Okay, so if you were going to type in a quadratic into the calculator, is it always going to draw a parabola for you? Yeah, it's always going to draw a parabola, but remember that solving by graphing, I'll go through this again so you guys can realize what I'm talking about, but what you're looking for is where the function crosses the x-axis. Okay, so do all parabolas cross the x-axis? No. Okay, so not all parabolas will cross the x-axis, so you cannot find imaginary solutions by using the graphing technique. Okay. Also, sometimes you don't get exact answers. So like if you had an exact answer of a square root of 2, you would get a decimal answer using the calculator rather than an exact answer. Okay, so graphing is only sometimes a method. Okay, so let's do a couple of these examples. Okay, I want you to take a look at this and tell me which method you think is the easiest one in order to solve it. Okay, so we want to do the easiest method, the most efficient method, or at least the method that you are good at. Okay, so how would I do question number 2? What method would you use? Quadratic formula? Okay, I can't disagree with the quadratic formula. Is there another way to do this? Can we factor it? We can certainly try. Okay, which method would we use? Remember there's 2 methods of factoring?
The easy method.
Easy, and then you have the not box and the box method, right? Okay, so we got the easy method and the box method. So this is the easy method. So do you guys remember how it goes? Which 2 numbers multiply to the last and add to the middle? -3 and -4. So those are your 2 quantities. Okay, so this is going to factor into x minus 3 and x minus 4. And then how do I come up with what x is equal to? What do I do with those 2 quantities to solve for the x? Set them equal to 0, right? Okay, so you might not write this, but I'm just going to write this because I'm showing my work. Okay, so if I solve for the x on the x minus 3, what is one of the solutions? X equals 3. And what about x minus 4? What does that solution give me? 4. Okay, so hopefully you can do that in your head. Good there? Okay, let's try number 3. Which method would you use to solve question number 3? Square root method? Is there any other method that I could use?
Quadratic.
Could use quadratic formula. That should always be an answer, right? Can I factor this?
Yes.
It is factorable. But let's do the square root method because it's the easy way. So remember, square root method is just to isolate the x. So how are we going to get x all by itself? What would you do first? Good. So I start by adding the 64. So 36x squared is equal to 64. Then what? Divide by 36. What is 64 divided by 36? Okay, so we can leave it. We don't need to reduce this because they're both perfect squared numbers. The next step is going to be to square root. So what is the square root of 64/36? 8/6, which is 4/3. What do I not forget? Good, plus or minus. Yeah, don't do that. Don't forget. Okay, that was pretty easy. Alright, what about this one? Number 4, what method would you use? And first of all, what do we have to do before we even pick a method? Okay, good. So the first thing I always have to do, and it doesn't matter which method I am using, I need it to be set equal to 0. So x squared minus 4x, I'm going to subtract 2, so that gives me minus 5. Okay, so now which method should I use? Okay, we could certainly try factoring. Okay, so to start this, to see if it's factorable, I would multiply the 4 times -5, which is -20. So are there two numbers that multiply to -20 and add to -4? Multiply to -20, add to -4. 1 and 20, 2 and 10, 4 and 5. So since there's no two numbers that make that work, we can't factor it. This is an unfactorable quadratic. So what's my method? Quadratic formula. And it is the only way to solve this to get an exact solution. So here we go. Quadratic formula. Starts with negative b. What's my negative b value? 4. So 4 plus or minus the square root of 4 squared minus 4 times the a times the c, all divided by 2 times the a. Perfect, yeah. Okay, so I want to do the inside of the radical first. Okay, so on the inside I have 16. 4 squared is 16. And then, does everybody see I have minus negative? So I'm going to say plus. And then I got, I'm going to multiply 4 times 5 first, and then, because that's a nice, easier number to work with. 4 times 5 is 20, and 20 times 4 is 80. Like 80, that's not too bad, all over 8. So what's 16 plus 80? Ew, 96. That's not as nice as I thought. Okay, so now we got to break 96. First of all, is 96 a perfect break? No. Okay, so what perfect square number goes into 96? 16 times what? 16 times 6. Good. Okay, so can we do this mentally? If 16 times 6 is 96, what's the break of the square root of 96? No? So 16 times 6. So what's the square root of 16? 4. So 4 squared root of 6, right? 4 squared root of 6. Everybody follow that? Okay. Am I done?
No. No, it's.
Yeah, I can reduce. By what number?
2.
Bigger. 4. So when you reduce, make sure that you guys are reducing. Hey, Trey and Hayden, focus here. I'm going to do like 2 more questions. You can't touch the radical when you reduce. Okay, so we're just looking at the 4, and the 8. So we can reduce by 4. So we get 1 plus or minus the square root of 6 all divided by 2. And that's reduced. Good there? Okay, so moving on to question number 5. What's my first step on question number 5? Subtract the 1. So I need to set it equal to 0. So I get plus 1, right? Equals 0. Okay, now this one is factorable. Okay, so we're going to do the box method to factor this. A little refresher. So we got 8x squared, we got 1. So 8 times 1 is 8. What two numbers multiply to 8 and add to 9? Add to 9. 1 and 8. So don't forget your x's on that. Whoa. So 1x and 8x. Okay, what's the greatest common factor on that top row? X, bottom row. 1. First vertical. 8x, second vertical. 1. So this factors to 8x plus 1 and x plus 1. Set equal to 0. So am I done? Okay. So remember, I have to set each of them equal to 0. Now some people can do this mentally, which is totally fine. Okay. On our left equation, we have to subtract 1 first and then divide by 8. Okay, so we get negative 1/8. And then I think the other one you can do, if we have x plus 1, negative 1 as our other solution. Good there? Okay, so the last method, the one we have not hit yet, is solve by graphing. So let's do one where we're going to solve by graphing. Let's do number 8. So let's pull this to the side. All right, so you need to do this on a calculator. Okay, so everybody grab their calculator. I'm going to grab my Webbit. Okay, so the first thing that I want to do is I want to type this equation into the calculator. And the idea that I'm doing here is that I'm kind of doing 3x squared minus 6x is equal to y. Right, so if I'm using my calculator, I'm going to go and I'm going to hit y equals. I'm going to clear out what was there previously. And I'm going to type in 3x squared minus 6x. That's what my y is equal to. So 3x. X is right by the green button.
Oh.
See where it has X?
Yep.
Zero-y thing, which is an angle. And then squared. Everybody find the squared button. Minus.
Click alpha and then X.
Yep, it does still work. Yep. Okay, so once you've typed this in the calculator, what you should always hit when you are using a new calculator and graphing for the first time, always hit zoom 6 because potentially the last person that used it was in a weird window. Okay, so always hit zoom 6. So it takes you to a standard 10 by 10 window.
Can you graph it and then put that in?
What do you say that again?
So like, you click zoom
6.
then graph.
6 will take you straight to the graph once you hit the 6. All right, so what am I looking for? Where am I going to find these solutions at? Very good, the x-intercept. So I'm simply looking for the x-intercepts, which is where I made the y value 0. Okay, so notice my equation is set equal to 0. So another word for the x-intercepts is where are the zeros? Okay, so what I'm going to do, the calculator, I'm going to hit second trace. Second trace. And anybody want to make a guess as to which one I'm going to choose? The zeros, because we took that equation and we set it equal to 0. So we're going to choose question number 2, or option number 2. All right, so at this point, I'm going to use my cursor, and it asks me a question. It says, go to the left of it. Give me the left bound. So right now, my cursor is exactly on, well, the point I'm looking for, in fact. But I need to go to the left of it. So using your left and right arrow buttons, actually just the left one, you're going to go to the left. Okay, and when you go to the left, what I want you to notice is number 1, you see where my cursor is, like on my grid. So I am currently at the point negative 0.4. I'm looking at this x value right here. Okay, and notice that negative 0.4 is to the left of 0. Right? It's less than 0. Okay, and also notice, are you above or below the x-axis? You're above. Okay, because when you hit enter, the next question is go to the right of it. Okay, which means if I was above, I'm going to push my cursor to the right until I'm below the x-axis. Okay, and once I'm below, I'm just going to hit enter. Okay, and when I'm done, I should have 2 little arrows that pop out on the guess. As long as these 2 arrows are pointing at each other, and it looks like my point is kind of in between those 2, then I just hit enter. I don't need to move my cursor at all, I just hit enter. Okay. And my solution is going to pop out. Did anybody else get 0 as one of the solutions? Okay. Did anybody not get 0? Okay. All right, so I'm going to come over here and say one of my solutions is 0. And I could see that there was a second solution. Okay. So on my second solution, what am I going to do? I'm going to go through the same steps with the calculator. Where did I start? So it's already in there, though. But how do I find that point? Second, trace. There you go. Okay, so we're going to hit second, trace, and we're going to choose the 0, number 2. Okay, and I'm going to put my cursor really close to that spot, if it lets me. So try to get your cursor as close as you can to that spot. It'll take me like 3 or 4 days to get there. Hold on. Okay, now before I hit enter, I want to make sure that I'm on the left of that spot. Okay, so I'm going to hit the left arrow key at least 2 times. Okay, and I know that I'm on the left of that spot. Okay, so I hit enter. Okay, I'm going to notice, am I above or below the x-axis right now? I'm currently below. Okay, so now to go to my right bound, I'm going to go right, right, right until I'm above the x-axis. Okay, once I see the cursor above the x-axis, I'm going to hit enter. It's going to pop out an arrow. When the 2 arrows are pointing at each other, it looks like roughly my spot somewhere in the middle of that. I just hit enter again, and it should pop out my second solution. So what's my second solution? 2. Did anybody else not get 2? Or everybody get 2? 2? 2. Okay, so this is absolutely a method for you to solve quadratics. Okay, now the thing about this is there's not any work. Okay, so if you do choose to do that, you need to tell me, first of all, what equation you typed into the calculator, and then your solutions, and you have to tell me that you're using the calculator to solve it. Okay, also make sure you have exact solutions. So that means if you get an answer like 2.1357982, I don't know, whatever, is that going to give you an exact answer? No. Okay, so that means you need to use like quadratic formula in order to get an exact solution. Okay, the other hiccup in graphing, okay, let's say that I was going to solve this scenario instead. 3x squared, and let's say this was a plus. I'm going to show you why graphing isn't always a good method. Okay, so plus 6x. So when I hit graph, oh wait, that wasn't the right one. Sorry. Let's just do, let's just add 6 at the end of this. If it lets me. Good Lord. There we go. Okay, so let's say we add 6 at the end of this. Perfect. Okay, so I get this as my parabola. You see what the problem is here? There's no x-intercepts. Okay, so when you have a parabola that is either above or possibly below when it goes upside down, and it doesn't cross the x-intercepts, what kind of solutions would you find? There would be solutions, but they happen to be imaginary solutions. Okay? So this quadratic still has solutions, they're just imaginary. So you'd have to use the quadratic formula to find those imaginary solutions. So they would have eyes in them. Does that make sense?
So you can use that for all of them except for the group. Yep.
As long as you get an exact answer.
Right.
Yep. So we good?